Oh, yeah, that's right. Times this. Times this. So this cancels with that. This is equal to Kn, excuse me, Kn plus 1 times Kn factorial. And that's Kn factorial and that Kn factorial cancel. This is equal to n plus 1 times n factorial. That n factorial cancels with this. N plus 1 cancels with that. And that's the end. So in the end we get q of xn plus 1 equals 1, given x1, x2, and so on up to xn, is equal to kn plus 1 divided by n plus 2. So, that's actually pretty interesting. If n is 0, then the sequence from x1 to x0 is obviously empty. So this is the initial element. So q of x0 plus 1 is x1. Oh, firstly, sorry, let me back up. That's for q of xn equals 1. Xn plus 1 equals 1. Q of xn plus 1 equals 0 is the other possibility. Now, we could go through the entire derivation again, but what's a simpler way?
1 minus.
1 minus. So there's only two possibilities for xn plus 1. This is 1 and that's the other. So therefore this must be 1 minus kn plus 1 divided by n plus 2. Actually, that has an interesting interpretation. That is n plus 2 minus kn plus 1 all over n plus 2, which is n minus kn minus kn minus 1 plus 1. N minus kn plus 1 divided by n plus 2. What is this?
Zeros.
It's the number of zeros, exactly. So in some sense, this is counting the number of ones approximately. For large n, this is approximately the number of ones divided by the number of elements, and this one is the number of zeros divided by the number of elements. So we have exactly what we set out, or we have almost what we set out to achieve, which is basically counting the number of ones and zeros. So, if n is 0, I have q of x1 given, okay, given from x1 to x0, there's nothing there, that's a null sequence. So I have this q of x1 is equal to, okay, k0, let's say the initial number of ones is 0. I haven't had any, there's no sequence. So the number of ones I've had so far in the sequence must be 0. And n is 0, so that's 1 over 2. Which makes sense. So if I don't know anything in advance, it makes sense that I should start with 1/2. So let's see some examples with this.